3-6, Compound Inequalities. So our objective for this section is to solve and graph inequalities containing the word and to solve and graph inequalities containing the word or. And our essential understanding is that you find the solutions of a compound inequality, either identifying where the solution sets of the distinct inequalities overlap, or by combining the solution sets to form a larger solution set. And the way that we're going to tell which one is which is by the type of word that is in the problem, and or. So the graph of a compound inequality with the word and contains the overlap of the graph of two inequalities that form the compound inequality. So if you look at my first inequality, x is greater than or equal to 3, and x is less than or equal to 7. If we say the first one and the second one, we want both to be true. We want the first one and the second one. So in order for both of them to be true, you can see that the red one goes to the right, the blue one goes to the left, and in between, the place where they are both true is going to be between 3 and between 7. The difference between an or inequality is that the graph of a compound inequality with the word or contains each graph of the two inequalities that form the compound inequality. So this one faded out a little bit. So we have x less than -2, which goes to the left. X greater than 1 goes to the right. And now if we want one or the other, right, we just want one of them to be true. That's what that means, right? One or the other doesn't mean both have to be true. One could be true or the other one could be true, as opposed to the and inequality where both must be true. So for our two inequalities, the trick is to realize whether it has an and or an or to decide what our answer is going to be. Okay. We can rewrite a compound inequality involving and as a single inequality. Okay. For instance, in the inequality above, you can write, well, on the last page, we can say x greater than or equal to 3 and x less than or equal to 7. Okay. I can flip this first one around and say 3 less than or equal to x. This one can stay the same. And basically what happens is I can just take these two and shove them together. Ooh, well, didn't work. That was going to be a good idea. But let's try again. We can take it and shove it together, just like that. Okay? So we now have a compound inequality. And the way we read this is we start at the variable. We say x is greater than or equal to 3 and less than or equal to 7. Another way to read it is x is in between 3 and 7 inclusive, right? Because x is in between these two numbers on the outside. And inclusive means or equal to. They both include 7 and 3. All right. This is only possible if my variables are the same, if we're comparing the same stuff to the numbers, right? If we have it solved, or if there is the same expression for both, and we're looking for an and inequality. So let's make a compound inequality that represents the phrase and graph the solutions. So my first one, all real numbers that are greater than -2 and less than -6. So we can say all real numbers n that are greater than -2 and n is less than just 6. N is less than 6. And because these are both equal to the same variable, I can flip this one around and n is less than 6 and smush them together to say that -2 is less than n is less than 6. so that n is in between -2 and 6, or we can say that n is greater than -2 and less than 6. So to graph this solution, let's call this one -2. That's -1, 0, 1, 2, 3, 4, 5, 6. And we are going to have an open circle on both numbers, and the answer is going to be the space in between them. And there's my compound inequality. Let's look at B. All real numbers that are less than 0 or greater than or equal to 5. So the or inequality means I can't put them together, but now I can just rewrite these as n is less than 0 or greater than or equal to 5. So n is greater than or equal to 5. So my number is greater than or equal to 5. Okay? I start 0 right here. 1, 2, 3, 4, 5. Okay? This one is going to be an open circle, and it is going to go to the left. And this one is going to be a solid dot and go to the right. So clearly, in part B, comparing part A and part B, in part A, we have a region where my answer is in between two numbers. In part B, we have two arrows going in opposite directions. So usually, an and inequality will overlap and go in between two numbers, and an or inequality will go away. An and inequality converges, and or inequality diverges. So let's try a got it problem. For parts A and B below, write a compound inequality that represents each phrase. Graph these solutions. So my first one is going to say all real numbers that are greater than or equal to 4 and less than 6. So let's just use x as my variable. X greater than or equal to -4 and x less than 6. Flip that around. -4 is less than or equal to x, and x is less than 6. Smush them together. -4 gets less than or equal to x is less than 6. So x is in between those numbers. I might not have the space here, so let's -4, -3, -2, -1, 0. 1, 2, 3, 4, 5. Oh, whoops. Let's go like this. And let's just go by twos. -4, -2, 0, 2, 4, 6. Okay, so we have a solid dot there, an open circle there, and my answer is going to be in between. Now, if I didn't see that, okay, I could always go with each one separately. I could do a solid dot there, and this answer goes to the right. I could do an open circle there, and this answer goes to the left. And my answer then would be the place where these two overlap. So the answer would be this part right there. Okay. Let's do part B. All real numbers that are less than or equal to 2.5. So x is less than or equal to 2.5, or greater than 6. Okay. Let's call this 2, 3, 4, 5, and 6. So I'm going to go with a solid dot. I'm sorry. Yeah, solid dot at 2.5. And I'm going to go to the left. And then an open circle at 6 and travel to the right. Okay. Part C says, what is the difference between x is in between -5 and 7 and x is in between -5 and 7 inclusive? Well, the difference with this word inclusive is whether or not you use a less than or less than or equal to. So the first one here is going to be -5 is less than x is less than 7. Inclusive would mean negative 5 is less than or equal to x is less than or equal to positive 7. Okay, one includes negative 5 and 7, the other does not. Okay. So the solution of a compound inequality involving and is any number that makes both inequalities true. And one way you can solve a compound inequality is by separating it into two regular inequalities. So for this one, I could, if I wanted to, solve a compound inequality by separating it into two. So negative 3 is less than or equal to m minus 4, and m minus 4 is less than negative 1. Okay, so I could add 4 both sides there to give me 1 is less than or equal to m. Add 4 to both sides here to get m is less than 3. So my answer is in between 1 and 3. So, 0, 1, 2, 3. So it's going to be a solid dot right there, an open circle right there, right? This travels right, this one travels left. That's good, they overlap right in between there. Okay. Let's look at that again. Okay, in this method, we are going to separate the equation into two separate parts. So, negative 2 is less than 3y minus 4, and 3y minus 4 is less than 14. Start by adding 4 everywhere. So we have a positive 2 is less than 3y. Divide both sides by 3, and we get that y 2/3. Add that, we have 3y is less than 18. Divide by 3, and we get y is less than 6. So, let's go 0, 1, 2, 3, 4, 5, 6 on my number line. And because of the and, these should overlap. 2/3, we're going to go to the right, opposite here because the variable is on the right-hand side. And then y is less than 6 goes to the left. So open circle there. A solid circle on 2/3, which is about right there. And I connect the space in between them. We can also solve an inequality like negative 3 is less than or equal to m minus 4 less than negative 1 by working all three parts of the inequality at the same time. Which means instead of separating it into two parts, I can just add 4 to all sides of the equation, which then gives me 1. The 4's cancel, m, and 3, which is what I got in the first problem. Okay? You just have to be careful, though. Every time there's an inequality symbol, we have to do the same thing to all sides that are represented in the inequality. So let's use this method in problem 3. So to earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusive. Excuse me. You scored an 86, an 85, and an 80 on the first 3 tests of the grading period. What possible scores can you earn on the 4th and final test to earn a B in the course? Well, remember how you get an average. So my average is going to be the sum of all the tests, including the last one, divided by 4. And I want this number, whatever it happens to be between 84 or 86 inclusive, so or equal to. Okay, well, before we get going with this, let's simplify. Let's add up the three scores. So we get 84 is less than or equal to 251 plus x over 4 is less than or equal to 86. So now, whatever I do, I have to do to all three parts of this inequality. The left side, the middle, and the right side. So I'm going to multiply by 4. Okay? So that turns into times 4 and times 4. So what that will let me do is cancel out these two 4's. So now I have 84 times 4, which gives me 336 is less than or equal to 251 plus x is less than or equal to 86 times 4 gives me 344. Subtract 251 from all three places, which would give me, those cancel, x, do the right hand side first, which would give me 93, and then 336 minus 251 gives me an 85. Okay? So I have to get between an 85 and a 93 in order to earn a B in this course. So for this one, suppose you scored a 78, 78, and 79 on the first three tests. Is it possible to earn a B in the course? Assume 100 is the maximum grade you can receive in the course and on the test. Okay, so same thing. I want to get a B, which is going to be in between 84 and 86. So my new three tests are 78 plus a 78 plus a 79 plus my last one. And obviously looking at these grades, which are all much lower than an 84 or an 86, I'm not sure if this is going to be possible. But let's try. So 78 plus 78 plus 79 is going to be 235. Whoops. 235 plus x over 4 is going to be less than or equal to 86 and 84 on the left. Multiply everything by 4. Gives me again my 336. 235 plus x. And 86 times 4 again gives me 344. When I subtract 235, I get x in the middle, I get a 109, and 235, 336 minus 235 gives me a 100. So that means, whoops, typed in the wrong thing in my calculator. 336 minus 235 is a 101. So that means that it is not possible for me to receive a B in this course. Came close to the lowest B, an 84, but I would need a 101. So the solution here, ask your teacher for extra credit. So the solution of a compound inequality involving OR is any number that makes either inequality true. To solve a compound inequality involving OR, you must solve separately the two inequalities that form the compound inequality. So there's no tricks here. Basically, all we have to do is solve each piece separately and get to the answer. So let's start with the first one, or this one. So let's start with the first one. Minus 2 from both sides. That gives me 3t is less than negative 9. Divide both sides by 3. And we have that t is less than negative 2, negative 3. Okay. Subtract 5 from both sides here. Gives me negative 4t is less than -4. Remembering, of course, the most important rule about inequalities, which we haven't seen yet in this section, is that if I multiply or divide by a negative number, I have to reverse the inequality sign. Okay? So now we have -3, -2, -1, 0, 1. Okay? We have a open circle, and my graph is going to go to the right. And for -3, I have a open circle as well, with my graph going to the left. Okay? Remember, of course, my important rule. So our got it problem. Again, solve them both separately. Subtract 7 from both sides, -2y. Let's get some room here. -2y is less than -6. When I divide both sides by a negative number, y becomes greater than +3. Subtract 3 from both sides here. So we have 4y is less than or equal to -8. We're dividing now by a positive number. It doesn't matter that my answer was negative. We just get -2. Okay. So if I start here at -2, 1, 0, 1, 2, 3, here's 3. We're going to have an open circle going this way and a solid dot with my graph going to the left. Okay. So the last thing we want to talk about is something called interval notation. So we can use an inequality such as x is less than or equal to -3 to describe a portion of the number line called an interval. We can also use interval notation to describe an interval on the number line. Interval notation includes the use of 3 special symbols. These symbols include parentheses, when we're going to talk about a less than or a greater than symbol. And it indicates the endpoints, the interval's endpoints that are not included, right? Because we're just less than or greater than, we're not or equal to. So we use brackets when we want to say equal to, okay? When we have less than or equal to or greater than or equal to. And this symbol indicates the interval's endpoints that are included. Finally, we use the symbol for infinity when our interval continues forever in a positive direction. And we use negative infinity when the interval continues forever in a negative direction. So let's look at a couple examples of this. And you can see that if we want to say x is greater than or equal to 2, we start at 2 and we go forever to the right, including 2. So we use the bracket, comma, infinity, parentheses. Always use parentheses when you talk about infinity, because you can never actually get equal to infinity. There's always further to go. That's the definition of an infinity. It's going to keep going and going and going forever. So whenever we're dealing with interval notation, we always use parentheses for infinity or negative infinity. So if we're going to say x is less than 2, now everything gets parentheses. So we use parentheses, negative infinity, comma, +2. Our interval notation is always going to go left to right. We're always going to start at the smaller number, comma, the bigger number, always. Okay? So if x is in between 1 and 1 and 5, we would use a 1, comma, 5 with a bracket because of the dot and the open circle. With an OR inequality, we have to list each part separately because there's 2 parts. So we can say this, or a fancier symbol that you'll see later is we can use a U for union. Okay? Putting these 2 sets together, the first one or the second one. So what is the graph of -4, comma, 6? So if I start this, if I have enough room here, -4, 0, 1, 2, 3, 4, 5, 6, just barely. Okay, so this means that the bracket means I'm going to put a dot. The parenthesis means I'm going to put an open circle. And this interval means that we are going to cover everything in between those 2 numbers. Okay. How do we write it as an inequality? Well, because x is everything in between that, we go -4 less than or equal to x less than 6. And if we wanted to write this in notation like we used in the last section, we can say in set builder notation, we could say x such that this happens. What is the interval of, but personally I like interval notation better than set builder notation or roster notation. What is the graph of x is less than -1 or x is greater than 2, and how do you write it in interval notation? Well, we should know the graph by now, -1, 0, 1, 2. So the graph looks kind of like that with a solid dot there and going this way. And because it's an OR, we're going to have to use two separate intervals. Always go left to right, always go from smallest to biggest. So we're going to start over here with -infinity, comma, -1 with a bracket because it's a dot, it's an or equal to, or parentheses 2 going all the way to positive infinity. Let's try a guided problem. So what is the graph of -2 comma 7, and how do you write it as an inequality? So the graph is, I know I don't have enough room here, so we'll start at -2. We'll go 0, 2, 4, 6, 7. So we're going to have an open circle. 2, 4, 6, sorry, 8. We're going to have a solid dot there. And my answer is going to be in between them. And the inequality for that would be -2 is less than x is less than or equal to 7. And what is the graph of y is greater than or equal to 7? So my graph of y is greater than or equal to 7. Let's clear this off. Let's just call 7 right there. We're going to say greater than 7. So we're going to say open circle. Boom, like that. My interval notation starts at 7 with a parentheses and finishes at positive infinity with another parenthesis. All right, so let's do our lesson check. And what compound inequality represents the phrase all real numbers that are greater than or equal to 0 and less than 8. So that would be 0 less than or equal to x less than or no, just less than 8. Okay? And the graph is going to go in between 0 and 8. Solid dot on 0, open circle at 8. What are the solutions here? So I would add 5 to all three sides to solve this very quickly. So it would go in between +1 and +4. Okay, so your test scores here, we should know how to do this by now. So you're going to do 83 and 87. What's the possible test scores on your next test? Have a test average between 85 and 90 inclusive. So we have 3 scores now instead of 4. So it's going to be 83 plus 87 plus x divided by 3. And we put 85 on one side, 90 on the other. And if you work this out, you should get between 85 and 100. Interval here is going to go from, goes forever. So forever is -infinity to 6 with a bracket because it says or equal to. So which of the following are compound inequalities? Yes, yes, no, yes. Gotta have two parts to be a compound inequality. Student writes the inequality x is greater than 17 in interval notation as 17 comma infinity. Why is that not true? Because the bracket indicates a specific number as part of, oh, okay. So there's the part that's not true. Sorry, I didn't see that for a second. We can only have parentheses for infinity. Okay? The symbol infinity means numbers continue without end. Always parentheses with infinity. So what are the solutions of this inequality or this inequality? When we solve that, we're going to have x is less than, add 7 to both sides, divide by 3. You can have x is less than or equal to 7, or x, oh, this is actually an interesting one. So let's look at this. So we have 3x minus 7 is less than or equal to 14, or 4x minus 8 is greater than 20. Add 7 to both sides. Oops, 7. So this is 3x is less than or equal to 21. Divide by 3. X is less than or equal to 7. Or add 8 to both sides. So 4x is greater than 28. And x, 4x minus 8, add to it. Yeah, okay, so 28. X is greater than 7. So if you need only one or the other to be true, if we look at a number line, we are saying that x, right here is 7, x is less than or equal to 7, so that's a solid dot going this way, and then an open circle going this way, but the open circle and the solid dot are the same thing. So this particular graph, which could be one answer or the other answer, contains every possible answer that there is. So every possible answer, how far that way, would be from negative infinity to positive infinity. All real numbers. Pretty ugly infinity. I'm not good at drawing them. I'm sorry. Okay. Compare the graph of a compound inequality and with the graph of a compound inequality or. Graphs with a compound inequality and usually overlap. However, you gotta be careful because if we were to change this problem right here to a or inequality, now because this one was going this way and this one was going this way, if this was an or inequality, which it can't be because it has a middle term there, but if we had two separate inequalities with the word or, this would be all real numbers as a solution from negative infinity to positive infinity. And also, if I were to change this to and, the answer would be the place where these two graphs overlap. They never overlap, so it would have no solution. Ugh. No solution. My pen's fading a little bit. I'll have to change the tip here. Okay, so that was 3-6 compound inequalities.